So when we come to these, I think these are one of the hardest so far, based on your level. But it's simple because every time we come across these and you substitute, let's say you direct substitute, you get infinity minus infinity. You get minus infinity minus infinity, or anything that has to do with, it's either minus, plus, infinity, anything that has to do with that format. It leads you to say that we need to cross multiply. You see, right? So every time we come across such, we need to cross multiply. So you see, when we do questions, if we come across these ones, we'll have to cross multiply. Then it will take us to this format. So when we get this, what we need to do is we need to say that first I'm gonna come and cross multiply. If I cross multiply here, I'll get 0 minus 1 plus 1, which is 0 here. Then on the denominator also I'm going to get 0. So after cross multiplying, this will lead you to either this format or it leads you to this format. You see, right? So that's what we're gonna do. So let's try to do this question. Let me check. Yeah, this one we already have it. Let me see if we can do any question. Yeah, let's discuss this one and see what we do to that. Yeah, I think so. We cross multiply, right? Then we substitute, we get 0 over 0. Then after getting 0 over 0 or infinity over infinity, this tells us that we can now derive the numerator and denominator individual, right? So given that if I derive, remember, if I derive e to the x, this is e to the x times ln e times the derivative of the exponent, which this will give us e to the x times 1 times 1. You see, right? Then now let's come to the second one, then we'll go to the tutorials. This is the same thing. When I plug here, I got infinity minus infinity. You see, right? The moment I get infinity minus infinity, this tells me that I should cross multiply. You see, right? Should cross multiply. When I cross multiply, I'm going to get this. Then after cross multiplying, I have to direct substitute. Then it's either get 0 over 0 or infinity over infinity. Alright, then now I can just come and derive this individual. So when we derive this individual, already we know product rule, we know how to derive sine, we know how to derive cos, we know how to do that, right? So let's say I derive sine x, I got cos x, this one I get 1. And then the denominator, I use a product rule. We know that if I derive x sine x, this will be, I can start by keeping one thing and derive plus, now I keep x and derive sine x. You see, right? This will be what? This will be sine x plus x cos x, which is this. So that is a product rule. Now after deriving that, now the numerator and denominator, I direct substitute again. When I direct substitute, I find that on the numerator I get 0, also on the denominator I get 0. So this is still in determinant form. You see, right? Then I'll derive again and get this. Now when I direct substitute, I realize that it's no longer in determinant form. Then I can direct substitute and get my solution. So this will happen for this. Now let's write this. I think, yeah, we can just do this. And then if we come to solve these questions, the first one says we're given the limit, says we have the limit as x approaches 1 of 3 minus 3 over x all over 5 minus 5x. You see, right? So if I just crop this out and cut, I think I've already opened the page. I paste this. So first, what I need to do is first I need to direct substitute. You see that I direct substitute. When I direct substitute, I find that this is in the form. If I direct substitute 1 on the denominator of this 1, 3 over 1, I get 3. 3 minus 3 is 0. Over, also here it's 0. So this is the form 0 over 0. So every time we solve these questions, I'd like us to write form. You write what form is this inside brackets, you give us there. And then, if we were in this format, it means that we can apply a L'Hopital rule. You see, right? It means that I can derive the numerator and denominator individually. All over. When I derive this, I'm going to get the numerator. I'm going to get the derivative. So let me write the derivative here of 3 over x. I'll get, this is the derivative of 3x minus 1. Then this is minus 3x minus 2. And this is minus 3 over x squared, which in this case will be 3 over x squared. You see, right? All over, this would be minus 5. So, if I just come and direct substitute here, I realize that this is no longer the form of 0 over 0 or infinity over infinity. You see, right? So I can just proceed and say, this is equals to 3 over 1 squared all over minus 5. Then this would be 3 over minus 5. Then I get the solution there. Hope we agree to this. So, now that is the first question. Now we come to the second one. The second one we're given the limit as x approaches infinity of x squared over e to the x. Now I just cut this out. I come and paste it here. So now when we come to this question, we first write the form. What form is this? The form of this is infinity over infinity. So this means that I can come and apply a L'Hopital rule. So I just have the limit as x approaches infinity. I derive the numerator, which is x squared. I derive the denominator, which is e to the x. Now when I derive the numerator, I get 2x over the denominator remains the same. Then we check, this is still in, I didn't write the limit. This is the limit, x approaches infinity over 2x over e to the x. When we check, this is still in the form of infinity over infinity. It means that I need to derive again. You see, right now I come and say this is the limit as x approaches infinity, and the derivative of 2x over the derivative of e to the x. And this is the limit as x approaches infinity over 2 over e to the x. Now if I direct substitute here, I get that on the denominator. So now let's see, what do we get when we direct substitute this? We get 2 over e to the infinity. So this would give us 0. It's right. So we should know this, that the limit as x approaches infinity of 1 over e to the x will always give us 0. That's right. So that is like 2 over x. Yeah, it's 2 over e to the x, which is 0 also. Doesn't matter the constant, can be any constant. So we get this. Now, I think, yeah, this one we had solved it even the last time. So now we come to, we look at the third one. So I can just do this. Let me check. Look at there. we look at the third one. We have here, we have the limit as x approaches infinity of 5x minus 1 to the third all over 7x minus 2x to the third. So I can just carry this, I can just cut this out. So what we do first is we check the format. Well, what form is this? What is this indeterminate form? The form is if I substitute infinity on the numerator, I get infinity, denominator, I get infinity. You see, right? So this will be equals to the limit as x approaches infinity. Now I can derive the numerator and denominator. Minus 1 to the third all over derivative 7x. Is it 7x minus 2x? No, it's impossible. 7 minus 2. So when we derive this, we're going to have the limit. The limit as x approaches infinity of, we drop the 3, keep the inside, we have squared times the derivative of the inside, which is 5. We have all over, we have 3, 7 minus 2x squared, derivative of the inside, which is minus 2. So if we check, the 3 will cancel out, then we can take out minus 5 over 2. We have the limit as x approaches infinity of 5x minus 1 squared all over 7 minus 2x squared. Then if I check the form here again, the form is infinity over infinity. So I can just derive again. When I derive again, I get minus 5 over 2, the limit as x approaches infinity, the derivative of 5x minus 1 squared all over d over dx of 7 minus 2x squared. Then this will be minus 5 over 2, the limit as x approaches infinity of, I'll drop the 2, 5x minus 1 times the derivative of the inside is 5 all over 2, 7 minus 2x times the derivative of the inside is minus 2. So the 2 cancels out, then I have my minus there is 25 over 4 times the limit as x approaches infinity of 5x minus 1 over 7 minus 2x. Then still, if I check the form of this, it gives me infinity over infinity. So it's possible having the form of that being 3 times. It's possible to apply L'Hopital 3 times, as you can see here. Then this will be 25 over 4 times the limit as x approaches infinity of d over dx of 5x minus 1 all over d over dx of 7 minus 2x. So this will be 25 over 4. So the limit as x approaches infinity. If I derive this, I'll get 5 over minus 2. You see, right? Then this will be, so if we get 5 times 25, it means that we're going to have minus 125 over, and then 4 times 2 is 8. So this is the solution. So it means that the solution to this is that. So, any question on that? Now we come to 4. 4, we have the limit as x approaches pi over 2 of cos squared x all over sine x minus 1. So if I cut this out, this will be first we check the form. If I substitute pi over 2 there using radius, if I substitute pi over 2, question is what do I get? Then let me substitute that and see. Pi over 2, obviously it's 90. I get 0 also on the denominator. So this is the form 0 over 0. Obviously sine of pi over 2 would give us 1, and then 1 minus 1 is that. And then now it means that I can derive. Then I can derive the denominator and the numerator individually. All over d over dx of sine x minus 1. And this would be the limit as x approaches pi over 2. Then here I'll drop the 2, I keep the cos, I subtract 1 on the exponent, times the derivative of cos, which is minus sine x. All over, derivative of the denominator would get cos x. And this would be the limit as x approaches this over 2. Then I'll have minus 2 sine x. Put it inside the brackets. Now this would be minus 2 sine of pi over 2. You know that sine of pi over 2 is 1. And this would be minus 2. You see, right? Then that will be the idea. And we know here, I'll remind you of this. We know that the derivative of cos squared x is equal to, this is equal to 2 cos of x times the derivative of cos of x. And this would be minus 2 cos of x sine of x. And then the derivative of sine to the third x, this would be 3 sine squared x times the derivative of the inside, which is sine x. And this would be 3 sine squared x cos x. You see, right? Something like this. So we're done with this. And then we come to number 5. Number 5, we have the limit as x approaches 0 from the positive of cos sec x times ln 1 minus sine x. So from here we would get to check it there. Form. This is in the form. When I check cosec of 0, we know that cosec is 1 over sine. So when I check cosec of 0, I get infinity. So this is infinity times 0. So the moment you get the format of infinity times 0 or 0 times infinity or infinity times infinity, or anything that is not 0 over 0 and infinity over infinity, tells you must do something. So here what we can easily do is by changing this cosec. We know what is cosec. Cosec is 1 over sine of x. We have terms ln of 1 minus sine x. So we can just put this like this. We have the limit as x approaches 0 from the positive of ln of 1 minus sine of x all over sine of x. This, if we check the form now, will be infinity, not infinity, 0. This will be 0 over 0. You see, now we can apply L'Hopital rule. So it means that this will be the limit as x approaches 0 from the positive of d over dx of ln of 1 minus sine x all over the derivative of sine x. See, right? This is the limit as x approaches 0 from the positive. If we derive this ln, we get 1 over 1 minus sine x times the derivative of the inside, which is minus cos x, because the sign is negative. You see, right? All over the derivative of sine is cos x. So we have this. The cos will cancel out the cos. Then we're going to have the limit as x approaches 0 from the positive of 1 over 1 minus sine x. And if we direct substitute, you have 1, 0, which is 1. Then that is the solution to this problem. So any question? If you have a question, you can ask. If no question, we can proceed. So now we come to 6. On 6 we have the limit as x approaches 0 of sine x over x to the third minus 1 over x squared. So now we have this. We can just put our question there. And then now we check the form. You see, right? Now when we check the form, this thing doesn't want me to change a color. So when we check the form of this, if I substitute infinity or 0, 0, that's gonna be 0 over 0, and this side will be, so 0 over 0, there will be infinity, minus this side is also infinity. You see, right? So when we check, we find that this is infinity minus infinity. That is the form. So we must do something. We can apply L'Hopital rule. You see, right? Then I will come and cross multiply. Say x squared times sine x minus x to the third all over x to the 5. Now when I check the form of this first, I realize that the form, or before I can even check the form, I can try to summarize this or simplify it, right? Let's try to simplify it so it can be simple. We can even try to simplify this. We factor out x squared sine x minus x all over squared x to the third. So this will be the limit as x approaches 0 of sine x minus x all over x to the third. Then we check the form. The form of this will be 0 over 0. That's when we can apply L'Hopital rule. The reason why I simplified this, I was avoiding to use product rule. So if you're able to factor out something and cancel out, you can do that. So this is, I can apply L'Hopital rule, just derive the numerator and denominator. Is sine of x minus x all over the derivative of x to the third. And this will be the limit as x approaches 0 of cos of x minus 1 over 3x squared. Then if we check the form, cos of 0 is 1, so the numerator is 0 over 0. So that is also that format. We apply this again. So this is the derivative. You must always show that you are deriving, right? Minus 1 all over d over dx of 3x squared. And this is the limit as x approaches 0 minus sine x over 6x. If I check the form again, the form is 0 over 0. So I can derive again the limit as x approaches 0 d over dx minus sine x over d over dx of 6x. So this will be minus cos of x, the limit x approaches 0 minus cos of x over 6. And this will be minus cos of 0 over 6. This will be minus 1 over 6. You see, right? And then that will be the idea behind this question. So we got minus 1 over 6. Any question? If you have a question, you can just stop me. But if not, we can continue. So now we come to 7. When we come to 7, we have the limit as x approaches 0 of 6 plus 6x plus 3x squared minus 6x, your minus 6e to the x all over x minus sine x. You see, right? And then this will be so first we check the form. The form here will be on the denominator 0 over the numerator will also be 0. So cos 6 minus 6 will be 0. So if we check this, we say the limit. Now we must apply L'Hopital rule. D over dx of 6 plus 6x plus 3x squared minus 6e to the x all over the derivative of x minus sine x. So this will be equal to the limit as x approaches 0 of 6 plus 6x minus 6e to the x all over 1 minus cos of x. So from here we check the form. The form of this will be 0 over 0. Then we now apply again L'Hopital rule. So be d over dx of 6 plus 6x minus 6e to the x all over d over dx of 1 minus cos of x. And this will be equal to the limit as x approaches 0 of 6 minus 6e to the x all over sine of x. Now if we check the form of this again, it will be 0 over 0. So we introduce the derivative again. We are applying L'Hopital rule. This will be 6 minus 6 e to the x all over d over dx of sine x. Then this will be the limit as x approaches 0 of minus 6 e to the x all over cos of x. This will be equal to minus 6 e to the 0 over cos of 0. And this will be minus 6 over 1, and the answer is minus 6. So we see that. Any question? If there's no question, it means we can move, right? And then now we come to number 8. On 8 we have the limit as x approaches infinity of 6x squared plus 5x plus 7 over 4x squared plus 2x. So first, we check the form. This is in the form of infinity over infinity. That means that we can apply L'Hopital rule. D over dx of 6x squared plus 5x plus 7 all over d over dx of 4x squared plus 2x. And this will be equal to the limit as x approaches infinity. This will be 12x plus 5 all over 8x plus 2. So now we check the form. The form again will be infinity over infinity. We apply the derivative again. For L'Hopital rule, we derive the numerator. It's 12x plus 5 over, derive the denominator. It's 8x plus 2. And this we're going to get the limit as x approaches infinity over 12 over 8, which this is 12 over 8. And we know that 12 over 8 is 3 over 2. So that will be the solution to this one. So if you have any question, I think this one was the simplest because everyone knows how to derive this. So now we look at number 9. Number 9, we have the limit as x approaches infinity of 1 over x minus 1 minus 5 over x squared plus 3x minus 4. We say, right? Actually, I was supposed to say try this. Can't write all of them. Let me say try this. Let's write 9. Let's write 10 even. So when you come to 10, 10 is usually what you find when you come to advanced calculus, SMTA 021. So this is what you find. E to the 1 over x minus 1. You find such problems. So now when you come to this, we know we're given the limit as x approaches infinity of this. Then if first we check the form, we realize that the form of here, the form is infinity times, that will be times 0. Let's say right. So when you get infinity times 0, we know that we're supposed to take something to the denominator. And you always take the one that is easier to derive. Is that right? So I'm going to take this to the denominator. When it goes to the denominator, it will go as 1 over x. Then, now I can check the form. When I check the form now, it will be 0 over 0. So, now we are going to derive both the numerator and denominator. Deriving the numerator, then we derive the denominator. This will be the limit as x approaches infinity. If we derive e to the x, we're going to keep e to the z times the derivative of the denominator. This will be minus 1 over x squared all over. If I derive the denominator, I'll get minus 1 over x squared. And that x squared will cancel out. I'll have the limit as x approaches infinity of e to the 1 over x. And this will be e to the 0, which is equals to 1. Then the solution to that problem will be 1. So we should know that the limit, remember from limit at infinity, that the limit as x approaches infinity of 1 over x will be 0. So we know that now this exponent is going to be 0 if we apply the limit. So this is the end of these questions of L'Hopital rule, the exercise. So yeah, I think the next part which you're gonna be doing is I want to check if they're gonna do the mean value theorem with you or not. So we just have to wait for class. For the time being, answer the tutorial which is given to you.
Jack? Yeah, let's go. Hey.
Do you guys have any question, or you just open your mic?
Oh, safety first.